So in this video we talk about the concept of interpolation and how we get specific numbers off the chart that may not necessarily be there. So let me just start out here with an example here. We have the saturated steam tables, and remind you it lists various temperatures here, various pressures, and once we know the temperature we instantly know what the pressure is and all the other properties going across here. And you'll notice here that the temperature is given at various intervals. So here, for instance, it lists 24.08 degrees Celsius, 28.96, 32.88, 36.16, 39, etc., all the way down that line. Now, what if we want to get some information about saturated steam at a temperature that's not listed on this chart? What if, for instance, I wanted to do temperature is equal to 31 degrees Celsius? Well, 31 degrees Celsius is not on the chart. We have here 28.96, 32.88. So 31 degrees is somewhere between these two lines here. It's not on the chart, but it's between here. So what we have to do is use a method called interpolation. And interpolation is really used to get information that's not present, but it's somewhere in between some data that we do know. So we do know some data about 28.96, we do know some data from 32.88, but we want to find out some information that's in between there using the information for these specific temperatures. So the idea behind interpolation is simply based on linear lines. So let me just draw yx. So let's just say I have this data right here. And this could be temperature versus pressure, this could be enthalpy versus temperature, whatever, it doesn't really matter. This is just x is the independent variable, y is the dependent variable, and we have some data that we've gone into the lab and measured, and we have all this great data, but we want to know at a point right there. What would be the data right there? What should y be for that value right there? Well, this is where we might, for instance, do this. We might just draw ourselves a line here. So draw a straight line that best fits the data as we can tell, and then we just go ahead and look at that line and find out where we are on that line and just read across here the y values once we're at the x value we have. So we just draw this line, and that helps us figure out, okay, what would the data be if I was trying to figure out between the data points? And that's exactly the concept of interpolation. This line, y equals mx plus b, is the nice if we know the y equals mx plus b formula, we have a nice mathematical way to go about finding data on this line right here. Really, with interpolation, what we're doing is we're finding a mathematical formulation for this line and applying it between data sets that are already known. Going back to our steam table example, we want to find out the data, for instance, the enthalpy at 31 degrees Celsius. So here's our formula that we'd use to interpolate. And this formula is really just derived from that y equals mx plus b. You can go through the mathematics and algebra of it, of trying to figure out what that line is, and then just figure out based on that to get various points, and that's really where this formula is derived from. Just drawing that line and going and getting some data in between the data points we know to get the pieces that are in between the known data points. So this formula tells us what would the enthalpy be at 31 degrees Celsius. So this is what we want. We want the enthalpy at 31 degrees Celsius, and it's equal to the enthalpy of the first data point. In this case, we may say 28.96 is our first data point. So let's just say we wanted the enthalpy of the liquid. So if I go over here, I'd read over here to the enthalpy, and 121.4 would be the value right here. And then it's plus H2 minus H1. Our second data point is 32.88, the one other boundary between the two. And so the enthalpy for H1 again is 121.4. H2 is just 137.7. And then T is the temperature at which we're trying to get the data at. That's 31 degrees Celsius. And then T1, T2, and T1 again are the data points that we do know. So T1 would be 28.96, T2 would be 32.88. So I could just go ahead and plug this data, the values from this table, right into this formula to get what the predicted value is at 31 degrees Celsius. So this is just the generic formula for interpolation. Y unknown is equal to y1 plus y2 minus y1 multiplied by x unknown minus x1 over x2 minus x1. So what are all these different variables here? The x's are just the independent variables. So in this case, that would be the temperature. And the y's are the values that we're trying to get. In this case, the enthalpy for this example. We want to really find y unknown at some x unknown value. In this case, we're trying to find what enthalpy is. The unknown enthalpy at the given temperature, 31 degrees Celsius. We could do this for other properties. We could do the same thing with internal energy. We could just substitute internal energy for y. X could be the temperature again. We could also use the specific volume for y's and try to figure out what a specific volume is at a temperature that's not listed on the chart. Again, x would be temperature. X doesn't have to be temperature, it can be other things. So we have pressure here. We have these various pressures, like here's 0.2, here's 0.25. I might want the properties, the enthalpy, at a pressure of 0.23, which isn't on the table. It's somewhere in between these two values here. So in this case, x's would actually be the pressures. So I would use the pressures here, and then y's in that case would be the enthalpy of what I'm trying to find, whether it's the enthalpy, liquid, vapor, or whatnot. And that's the general procedure for interpolation. We have to use this formula to find some properties of that were not listed on a given data set or given on a table. We have to try to figure out when they're in between known values. And we use this general formula right here to do that.